Okay, thank you for coming back early from the lunch, okay, so that we can start on time. Let me introduce myself. My name is Aris from SIT Singapore. Okay, I'm one of the PC members of EPNIC 60. Okay, so today I'm very happy that I will be chairing this sessions, technical session 4. In this session, we will have 4 different speakers, and I think all of them already here. So they will discuss about some of the open solutions and open collaborations on how to solve different network problems or requirements. Okay, so without any delay, I will introduce the first speaker, who is from Victoria University of Wellington. Please welcome Duncan Cameron, who will talk about the purple dynamic control of cake bandwidth parameters.
Excellent. Hello, everyone. I'm Duncan Cameron from Victoria University of Wellington, and it's my presentation about purple, or dynamic control of the cake Q disk. Cool. Oh, sorry. Looks like I have to stand by. So what's the actual problem here? What's purple actually trying to address? Well, the problem is active queue management solutions, such as flow queue control delay and cake or common applications kept enhanced. Control latency by flow queuing and keeping latency low, which is good. However, it requires you to have consistent link capacity. So if there's variation, such as what we can actually see in this diagram here, you end up actually having to set a compromised bandwidth. So this is basically like the conservative kind of margin where you're pretty certain that your sustained rate won't drop below that, or the sustained capacity rather of the link. So this is predominantly a problem on unlicensed wireless networks, such as sort of what's operated by WISPs, or these fixed wireless access operators. It is also a problem in cellular networks, of course. So yeah, essentially you end up losing quite a bit, and we don't want this to happen, but something that modern active queue management algorithms don't really deal with all that well. Oh dear, that's quite hard to see. Sorry. So you'll have to bear with me with this bit because unfortunately this is quite difficult to actually see here. Basically, you just have to take my word for it, but at the top here in the green, we actually see the radio's self-reported capacity, and along here, we see this is the sustained rate over it, so TCP throughput in this case. There's actually a lot of variability here that it's a little bit tough to see, but so on the left there, that would be showing up to around 160 megabits a second. However, at times this actually drops to sort of around 140. So in order to deal with, to actually set up something like cake where if you code on this link, you'd have to actually set a pretty conservative sort of safe capacity of probably somewhere around 140 megabits a second. But going back to that previous slide, we know that in doing that, we're actually losing a lot of potential bandwidth throughout the day. However, the variability can be sort of sub-second, so it's very, very difficult to actually change this on the fly without causing further problems. Oops. Sorry, seems to be having a. There you go. And just to give you some more context about this, so some particular radio vendors are better than others at actually estimating this capacity to start with, which sort of exacerbates this problem because you can't always actually take it at face value. So up the top here, we see, rather have a look at this one. We see the red here is a series of IPOE tests actually being run on this link. And we see in the light blue here, this is the radio's self-reported receive capacity. So at times what the radio's self-reporting that it can actually sustain is actually lower than what we actually are sending through it. So if we were to take and set the Q disk bandwidth parameter be whatever the radio says it is, a lot of the time we'd actually end up losing potential bandwidth, which obviously we don't want to happen. Which sort of leads us to the problem. Well, what do we actually trust? And unfortunately, the answer to that's not all that simple. So just for a bit more background to all of this, the cake order rate has some overlapping objectives with Purple. So effectively, it monitors the load, receive and transmit utilization, and ping response times from reflectors on the internet or locally. And it then adjusts Cake's egress and ingress bandwidth parameters to actually better tightly control that latency. And for some more background, this is something that both John Brewer, who's sitting in the audience here, and Ulrich asked me about at APNIC 58 in Wellington last year. And at the time, I didn't really have a good solution for them about what we can do here. And that was my motivation really for actually coming up with Purple and trying to do something better. And John, in another conversation, actually pointed out that some other projects around the world, such as very, very large Italian ISP Project Blue, actually using the ECNMP reported radio capacity values sort of at base value for traffic engineering decisions, which perhaps the radios they're using this is okay for, but certainly in some of the data I've seen to date, this would likely create some interesting challenges just with the reporting not necessarily being particularly accurate. And what about latency all this? So if we do just set a overly optimistic rate, what actually happens? Well, sort of imagine this as your router and everything at home. So you've got data coming in, you have a buffer in your modem, which is filling up, but your actual usable internet capacity can be represented by this little pipe coming out. So if you keep the rate coming in to be less than what this can actually flow out, you won't have problems. But if this exceeds that, your buffer ends up filling up and you get what's known as buffer bloat, which is a excessive queuing latency in essence. So if you have a low load connection, nothing bad will probably happen here. But under high load, you end up almost certainly with bloated buffers. And if you're an internet service provider, probably some very unhappy customers. And apologies, this is another quite difficult to see graph on this. So yeah, apologies. It's very, very hard to see here, but if we think back to the other slide, which was unfortunately also quite hard to see, so this is a huge latency spike here in that same particular link, which goes up to almost 300 milliseconds. So when that link that's been set to have a capacity of around 160 megabits a second in the HQ disk has reached very, very close to that utilization. So going up somewhere around that, the radio's reported rates dropped. We're actually seeing buffer bloat happen here and well, what was real time. So during that very high utilization, you end up with pretty poor latency over the network. Unfortunately, if you are just looking at long-term statistics, your averages of latency over any given links, they really don't capture this sort of poor performance that well because this is only happening over sort of 5 minutes and sampled every minute or so. So it can be very transient. But of course, you do also get these micro bursts, which happen on a much smaller time scale. And yeah, I can probably see it slightly better here. So we get bloat. So see, capacity is sort of all over the show. Drops in this case where utilization of links actually very, very high. So this is from it was actually a production wireless internet service provider a couple of years ago. And we then see this latency just skyrocket up. But the rest of the time, mostly okay. But yeah, you really can't trust averages of this. So the problem which Purple's actually solving here is with these static QDIS configurations, they really do fall short for this problem. It has to be a better solution. So moving on. And just some more evidence for you all. So in a laboratory setup with just 2-point radios, between these green lines here, we're running IPOE tests, and there's a pause and yet another one, and then a pause again. So we can see when there's no load over it, the latency is very good. It's consistently below 5.5 milliseconds. However, when we actually run these IPOE tests and load the link up, this skyrockets, on average, well over 10 milliseconds, going up to sort of around, 30 to 40 to 60 in some cases, which is obviously undesirable. And if you were a wireless internet service provider, having this happen any of the time of the day is really not acceptable. So to deal with all of this, introducing purple. So purple's inspired by both red and blue, now reasonably old queuing disciplines, but of course the combination of red and blue gives you purple, hence the name. So purple works by actually estimating the usable capacity of a wireless link, and it then controls buffer bloat through dynamic control of Cake's bandwidth parameter. And it uses precise one-way delay to actually input from the Polar scheme, which was introduced in APNIC 56 in Japan, to actually provide quite precise control for either the egress or ingress bandwidth parameters of Cake. Oh, sticking. So purple conceptually is very, very simple. So it uses the truly tried and tested AIMD algorithm, which was made famous by TCP, amongst other things. So effectively, you have a latency measurement come in. This is categorized. If it's good, sweet, you continue. You hold steady and you increase a counter for good latency. If it's bad, you, with the multiplicative decrease, actually cut the cut the bandwidth. So if it's really, really bad, by 10%. If it's bad but not terrible, by 5%. And if that counter here for normal latency goes over some given threshold, you then end up actually incrementing your bandwidth additively, say at 0.5 megabit per second or some other operator defined amount. And this just continues. And we'll have a look in a moment at actually what this looks like in practice. However, I did also make a non-AIMD version of Purple, which uses low-level Q metrics. And this is actually more precisely where the name Purple comes from, because it was inspired by red and blue, rather than using AIMD directly and with latency measurements. However, I quite quickly found out with this that unfortunately not all radio vendors really support giving me useful Q metrics that I can use to infer whether or not the radio's underlying hardware Q disk is full. So that sort of got sidelined in favor of the AIMD approach. And the evaluation setup for this was quite simple. On the right-hand side here, this was the first generation microtik approach that we took. And with this, unfortunately, I couldn't really get useful low-level Q stats out of it. AIMD approach there works completely fine. But for the actual unidirectional latency measurements that then feed into controlling that bandwidth parameter, we set up two Ubiquiti Loco 5 ACs with two Raspberry Pis with Adafruit GPS hats on them, which have a precision time sort of sync. So obviously for one-way delay to actually be useful, you need to have very, very precisely timed clocks, and they have to be, well, very closely in synchronization with one another, or the measurements are effectively useless. For this case, these do need to sort of be somewhere outside. They can actually receive a GPS signal. Once they're actually in sync, though, we then use that one-way delay measurement in either direction that you want to update the measurement parameter going into Purple, and then either increment or decrement the bandwidth. And performance results for Purple are very, very good. So we compared regular Purple using the Ubiquiti radios, where I could get lower level Q metrics, as well as Purple AIMD, also on the same platform. And we found that it like consistently outperforms the static and also sort of optimistic Cake configurations. So these are represented by Cake 100 megabit, which is the sort of, I think this particular wireless link that I'm setting Purple up to operate on can sustain 100 megabits a second of traffic. And Cake 150 megabit is where maybe you're a bit more optimistic and you think that you can actually sustain 150 megabits per second throughput over it. So Purple AIMD has absolutely no knowledge of the underlying link capacity. It requires a target latency to actually be set to then either decrease or increase latency. Purple Regular, on the other hand, tracks a safe capacity, which does sort of require you to have reasonable confidence in your radio vendor to provide you accurate stats about the legitimate capacity of the link. But the reason it tracks safe capacity is the top 15% of the queue is basically useless. There's too much latency experience with it. And we also compared it against just regular FQ Codel as default on the Raspberry Pis. So performance-wise there though, so it consistently, with a 5.5 millisecond target, does hold at around there, just as we'd want. And setting the wrong static bandwidth, say Cake 150 megabit, with this particular link, which has a legitimate capacity somewhere closer to 120 to 130 megabits a second under normal conditions, at least in our setup of it. It was just about as bad as not setting it whatsoever, or the default no bandwidth set FQ Codel approach there. And yeah, Purple AIMD in this case is the clear winner. You could, depending on your tolerance for latency over the link, either decrease the target latency or increase it if you did want more throughput at the expense of more latency. So it still does require some intuition about your wireless links and sort of how much, just how much tolerance you have for latency over them. So in this case, I thought 5.5 milliseconds seems like a sane amount of latency for this link. If you want 10, you can get 10, but it will cost you in terms of latency, obviously. So going back to the TCP-esque performance of this though, so of course AIMD, pretty much everyone's probably familiar with the sawtooth effect that you're used to with TCP, and we see this, of course, with this as well. So you see where latency increases, it starts actually decaying the rate back before ramping it up and doing this again and again and again, giving you that sawtooth effect. Grey line there is what the radio self-reported capacity is, and this red line here is the useful transmit capacity, and the radio self-reported transmit rate, which you might note has quite a bit of oscillation. It wasn't immediately clear when we actually ran these experiments what was causing that for quite some time, and it turns out it's actually a result of thermal throttling on the Raspberry Pis. So if you had to run this on a separate platform, you wouldn't get results that look exactly like that. It would hopefully look a little bit smoother, assuming you weren't getting any sort of thermal throttling happening. And overall, so there's unfortunately an obvious latency bandwidth trade-off. So FQ Codel with no bandwidth parameter set in the default configuration will give you the best throughput pretty consistently. Cake 100 meg static configuration, of course, will give you pretty much what it says on the box, unless the link drops below that, in which case you will have another problem with latency increasing because it's static. Cake 150 megabit performed pretty much just as well as FQ Codel. Purple Regular is a pretty good combination of the two of them, just given it tracks in this case, the rate less 15%. And then if it actually experiences any packet drops, or it can detect that the queue has reached its capacity, it will then decay the rate back down. But for the best part, Purple AIMD in this particular experiment with a 5.5 milliseconds target latency across the board performs incredibly well. The mean and median latency is very, very good, and actually sits quite a bit below the 5.5 milliseconds target. Of course, so to actually make Purple better in all of this, so I still do have aspirations of actually using the lower level radio metrics with the queue. It just really requires vendor support to actually do so. So with Ubiquiti radios and AirOS specifically, this isn't such a problem, but they do provide a little bit of a lagging indicator. So once that underlying radio hardware queue just fills up, the queue fills up, it's sort of already too late. You've probably experienced latency for like a number of seconds, or at least a few hundred milliseconds. Whereas if you're using quite aggressive one-way delay measurements with Purple AIMD, you can be very, very responsive to any change. So yeah, more open source support is needed. Probably more contributions from the community, of course, welcome with this all as well. It's still very much as a proof of concept written in Python, including some of the one-way delay measurement components of it, which could probably be improved somewhat drastically by re-implementation in a systems language. However, so reason for AIMD being used was just the simplicity of it, but it's not to say some other control algorithm wouldn't actually be more appropriate. There's no reason why you couldn't implement this with Cubics algorithm, for example. That would probably work better even. And just to sort of draw this all to a conclusion, so those of you that do know Dave Tart, he was responsible in part for FQ Codel, Cake, and the LibreQS project. He was a huge source of inspiration with all of this work, and was very, very prevalent in the community for actually tackling the upper bloat problem, or excessive latency under load. So before APNIC 56 in Kyoto, Dave said to me, if you can get Jeff Houston to hold up a LibreQS t-shirt, I will buy him a beer. And I'm pleased to say we did actually manage to get Jeff to hold up a LibreQS t-shirt. However, unfortunately, I don't believe Dave ever did manage to get Jeff his beer. And there is Jeff with the LibreQS t-shirt. Don't think he's in the audience here, but I do have a beer in my bag for him. If anyone can locate him, from the late Dave Tart. May you rest in peace. And thank you all for listening. That is Purple. It's available wine group website here. It's also available on GitHub for the proof of concept should you wish to actually try it out in your wireless networks. Thank you.
Okay, thank you, Duncan, for the very good presentations. So I think we still have time to maybe one questions. So if you have, you can come forward and then specify your name and affiliations and then ask for your questions. Anyone want to have a questions? No?
Well, thank you all.
Okay, let's give a round of applause to Duncan. Okay, let me introduce the second speaker, which is from Skytel, Mongolia. He will talk about the open source AAA for IPOE and PPPOE. So please welcome Sufbakhtar Edeni from Skytel.
Hello everyone, I am Squatter from Mongolia and I work at Skytel Mongolian telecommunication company. And today I would like to share AAA open source solution that our company has adopted our fixed internet service. About a year ago, our team initiated to deploy new project, BSS project. BSS means Business Supporting System. During the project, we faced a lot of challenges and standards, and one AAA was one of them. So at the time, our company using AAA, but that solution was very manually handled and insecure, non-standard. So we had to find the solution, and we found the free radio system, which we can customize to our requirements. Now, challenges were to integrate PSS system with a PNG router and for the broadband users. And next challenge is stable, reliable system. And next one is need to manage IPOE and PPPOE solutions controlled by unified system. And main challenge was budget. At that time, we didn't have a planned budget for that system. So we had to find solution. And here is our solution. First solution is develop API for our PSS system, and second one is change free radio systems policies and filters. And next solution is set attributes for the Huawei PNG router because it was very different. And set up redundancy for VRRP. And replication database and monitoring system we need. Then I decided to use those open source systems for the open source cluster. First one is free radios. Next one is REST API in Node.js. And KeepAlive, as we know, KeepAlive is Linux systems VRRP. And for database, we chose the MariaDB and its cluster solution Galera. So we deployed the two different cluster, one for PPPoE solution and another one for IPOE. And because the servers have different rules, for PPPoE rules are here, create user starts with BB. BB means broadband, and after 5 digits, BB. You might think, why does it have 5 digits? Because we can't handle million or over million users with that system. If we need to handle millions of users, we need to buy or develop more stronger system. So next rule is generate password. Password should be 4 digits long and BSS system generates every username and password. Second, next rule is set bandwidth, which means internet speed, and we for the PPPoE user, we set the bandwidth by bitrate, only bitrate. Sorry, my mistake. Only group policy. For IPOE, username policy is a little bit of different because IPOE username contains IP address and customer ADVLAN, provider ADVLAN, and domain name. And generate password is same as PPPoE, and set bandwidth is a little bit of different because IPOE users have two types. One is single IP user, another one is multiple IP user. We set the bandwidth for the single IP user only bitrate. For the multiple IP user, we set the bandwidth by group policy, same as PPPoE. After deploy the whole open source system, the biggest advantage was the IPOE solution. So we have achieved the following three things: provisioning, standard, and experience. For provisioning, BSS system can control the user information and IP address management. Standard, we got the standard connection secure broadband service, so we can integrate now any system. For the experience, we migrated all broadband users without any interruption. And here is our old and new AAA cluster solution architecture. This one is our old architecture. This one is our new architecture. From here, our API development part and table structure. I already added new column in the several tables. This column is here, count num. Count num column is stored contract numbers of the subscribers, and API uses those contract numbers through the API for the control system. In here, we changed some policy and filter of free radio system because IPOE username contains some special characters such as dot, at, and slash. So we need to allow these special characters for the IPOE username. For a stable and reliable system, we use it KeepAlive. I just mentioned it before. KeepAlive is Linux systems VRRP, and it works based on the priority. And we configured virtual IP address between the two systems, radius A and radius B. Here is the simple configuration of our virtual router. State is master on the radius A. Radius B should be backup. And here is the virtual IP configuration, real IP configuration, and some ports. On the BNG router, we configured the main AAA configuration, and I tried to load balance by MAC filter. That means requests with the with even MAC goes to the radius A system. Requests with odd MAC goes to the radius B system. If something happens on the radius A system, radius B handles all the requests. Database, the core of all solutions is the database, and I chose the MariaDB, and cluster solution, it's Galera. And here is the Galera configuration. It was very basic, and it's thanks to this basic configuration to replicate our database each other. System database architecture is same as router. Radius A's requests goes to the database A. Radius B's requests goes to the database B. If database A goes down, radius B handles all the requests by KeepAlive. You may remember I added new column named countnum and several tabs. So the first picture is write check table. This table contains the usernames and user status. For example, this attribute is clear text password. This user's service is active. If it's cancelled like this user's service is inactive. Second table is route group reply table. This table contains the group policy, and group policy contains some protocol and bit rates and session time. This table is route user group for the multiple IP users, and username linked to the group name, group policy. And this one for the single IP user and username linked to the output input bit rates. Just so BSS system needs to control AAA system, and here are some rules, BSS system rules for the IPOE. The first rule is BSS should handle all the IP address and customer age, provider age, VLAN management. And customer age VLAN starts from 1 to the 4094, and customer age VLAN starts 2900 to 4094. Second rule is IP pool has one CE VLAN. If pool reaches the limit, customer age VLAN increases by 1. That means next new connection should choose the new pool's IP, and customer age VLAN increases by 1. The next rule is if CE VLAN, customer age VLAN reaches the limit of 4094, provider age VLAN increases by 1. From here starts the last part of my presentation, which is some API logics and examples. I chose the REST API because REST API is more understandable and easy to recall newbie like me. And our API works like this architecture. The BSS system is client, server side is free radio system. The first API is create new user API. This API protocol is HTTP and method is post, and body contains few attributes: username, password, contract number, and group name. Second screenshot is backend query that uses all those values to the insert database. So I just mentioned it before, we have two types of users. If customer uses single IP address, we use this write reply attribute, and group name should be null. If customer uses multiple IP address, write reply should null, and group name should be filled, some group name. In here, change speed API. And it was very challenging me because we have two types of user and they are using different way set bandwidth. This one for the single IP user, and this API contains only one attribute named speed, and we set bandwidth by bitrate. You can see here this 50,050,000 means this user assigned the 50 megabits per second internet speed. Next one for the multiple IP user, we use a group name attribute for this API and write some group names in here. And for example, this group contains the 60 megabit per second internet speed. As we have two types of user, so customers want to shift each other from multiple to single, single to multiple. In this case, we use this API. If IP type attribute is single, shift from multiple to single. And in this case, we set bandwidth by bit rate. Another way, customer wants to shift single to must. We use this attribute IP type master and set bandwidth by group name. And here is some validations. Check the group name, user exists or not. For the multiple IP users, we have two APIs because customers wants to add their IP address or delete their some old IP addresses. In this case, we use increase IP address, decrease IP address APIs. Increase the IP address API contains for the multiple IP address, and we write the new IP addresses on the new IPS attribute. If customer wants to delete some IP address, we write the old IP, removed IP address in remove IP address, remove IPs attribute. Dunning process, as we know, the collection management, it involves the payment or restricted service. Dunning process have four APIs and one-way block for the restricted service and suspension for the suspension under customer request. And for the termination, we use delete user and reactive service. I've tried best to explain my system that I built, and here's our monitoring section. I also used open source solutions for the monitoring. For the data collection, log collection, I use Loki and visualize them by Grafana. You can see this screenshot. And finally, we have two different open source cluster, one for family clients, PPPOE, and another one for the entity users, IPOE. And here is the quick recap of our architecture. To conclude, I found the whole open source solution and wrote some codes and better understanding integration between BSS and internet service. Next time I planned to migrate my systems to the microservices and gather some data from Redact table and do the predict using machine learning. If you have any question, feel free to contact me via this email or WhatsApp. Thank you for your attention. It was Squatter.
Okay, thank you, Subaktar, for very nice words, very interesting. Is anyone have any questions to Subaktar? Oh, John.
Thank you all. John Brewer from New Zealand. Hello. Great presentation. You said if you wanted millions of users, you would have a different system. But I wonder, what are the resource usages on your servers? What is the CPU usage? What is the memory usage? Are you constrained now with the amount of users you have?
It was according to just my estimation, and I thought we use four virtual machines on this cluster, and it's worked almost all the resource use.
Almost all of the resources.
Yeah.
Oh,
Yeah. That's why I estimate that.
all right. Thank you.
Any other questions?
Great presentation. My name is Awal from Apening. I have a quick question about when you had to configure the attributes, did you need to talk to the vendors? Did you face any problem with some certain attributes support by some vendors, and the other vendors probably have their own attributes and you probably didn't find the right attributes, something like this? Did you face these issues when you implemented?
Yes, I understand. I asked attributes from Huawei team. Yeah.
Okay, great. Thank you.
you.
So it means they are very welcome to what you say answer your question about the attributes, right?
Sorry?
They are very welcome to. I mean, like they answer all your questions
Okay.
about. It. Okay, actually, I have one more questions. Do you have any plan to do the benchmarking with like commercial radio servers?
I'm not sure.
Okay, thank you. Please give round of applause to Subakhtar from Svetar. Yeah. Okay, let me introduce the third speaker, Tan Tang Pan from Senior Network Engineer in Vietnam. Okay, so he will talking about the NetConsole, which is open source tool to configure multiple switches. So please welcome Tang in the stage. Yeah.
Yes, good afternoon, everyone. My name is Thang. I'm a network engineer, and today I will present the NetConsole, an open source tool to configure multiple switches. And yeah, do you know that in Vietnam, we have many switches to still alive 20 years. I'm work in a network about 10 years, but some switch still alive double of my experience in networking. And almost the device are at the end of life end of sale and no longer supported by the vendor. And I see in the management, the network net admin who manage the network device often have uh, often given higher privilege than as they need in configuration. Uh, for daily task, they only need to configure in the interface mode, but uh, they can have the privilege 15 or admin role like root access. They can do anything on the switch. And another case, sometimes I receive an IP arrest or MAC arrest from the SOC team and need to find out which the interface connected that's endpoint. And but sometimes the endpoint was disconnected. And if I don't have any centralized solution to manage the network, the time is really actually time consuming. Yes. And have you ever deal with um, IP arrest conflict? That's uh, that's when one IP arrest show up with two different MAC arrests. Yes, and your net admin needs to find out which one is the correct one. And the usual process is we will look up the database and figure out which server was assigned as IP or who use it first. And I build the NetConsole to track in the IP to map REST. That means IP to map mapping with the first thing, last thing, and duration online on the system. And one big problem with Vietnamese company is the purchase for software solution. Uh, the director or the BOD can approve purchase of hardware, but software is the different story. Yeah. And my friends often ask me if I know any solution to manage an enterprise network like that. And I've been learning network automation. That's how I build the NetConsole. Yeah, NetConsole is the open source and centralized solution to manage network device, and it designed to focus on level 1 network operation, reduce the permission the net admin level 1 can do on the switch. And the key feature of the NetConsole is can configure multiple switches at once. This is some key feature with NetConsole. For the switch management, I will collect the system information, manage switch by group, and you can see in the interface mode that the NetAdmin can easily configure interface mode, change the access or chunk or shut down interface, enable show interface running config. For the collect information showing running on the switch, I collect the MAC address table, ARP, IP interface, and checking online duration with the first in, last in online on system. And the group config here, that means I can create, configure multiple switches. I will show you some web interface and hidden some private information. For the switch management, this is one dashboard. I collect the system information like host name, IP address, model, version of the switch. For the interface management, the NetAdmin can do interaction here. Change the interface configuration, shut down, enable, or show interface running config with the status here. For the MAC address management, I collect the MAC address table and checking last thing on the system. Yes. The same with the IP interface management, and we can check in the last thing IP on that interface. For the ARP management, that I collect all information about IP address mapping with MAC address and first in, last in, and on this, the NetAdmin can use your searching to find out which the MAC address online first on our system. This is the architecture with NetConsole built with front-end React.js, JavaScript, and back-end powered by Fast API, and the PostgreSQL database for data storage. And I use some Python library to interact with Swiss. Three main Python library I use here in Nonium NetMiko. Nonium NetMiko help me to access and configure multiple switches at once. Napalm help me to get in switch information in the JSON format that easily for me to show up on the web interface. I use Napalm to get system information, MAC address table, ARP, and IP interface. TTP is a template text parser help me to passing from the running config to the JSON format data and help me to easier to store on the web interface. For I have a number of future work here. Adding layer 2 security feature in the interface mode. It helps the NetAdmin can easier to interact with layer 2 security. Adding the DHCP snooping dashboard to manage the DHCP on the access switch. And currently it only supports the one inventory, file inventory, and I will integrate a new short chat network. And for the configuration revision number is NetAdmin to it can roll back the previous config. Yes, just on in my introduce and in my information. I also create some video demonstrate about some picture, and you can access my GitHub to know more, or you want to use it, you can access my GitHub. Yes, thank you.
Okay, thank you, Tang, for the very interesting work. So any questions from the floor regarding his work? Anyone? If you have, you can come forward
specify your name and affiliations, then start with your questions. Okay. Yeah.
Hi,
Yeah.
Anurag Bhatia, Hurricane Electric. Very good tool. Just was wondering if the same tool can be extended to pull other data, like say optical power or other things.
You said NAPAD?
Yeah, I mean, I'm saying the same tool set can be used to also pull optical power from each interface.
I don't know the same bit. I have many monitoring stuff can collect the information like that, but the checking the information about the first thing, last thing, and the old data, I don't know about any tool like that.
We'll try to take this offline.
It means
Yeah.
let me try to rephrase the question. Actually, it's possible to monitor the statistic from the interface.
Currently, they're not statistics, and I think the statistics, it's we should use the monitoring tool. It, mm, it's you. My tool is you for configuring, and you want to monitor. I think you should use the monitoring tool.
Yeah,
Yeah.
sure. Yeah, yeah. No, you're right. I was just bringing up one of the use cases which you may later consider. There are some really old alt switches I have seen with some friendly networks where they don't give optical power on via SNMP,
Yeah,
but they
yeah,
would give you on live command. So probably such tools can be plugged in just as a stopgap
Yes, that's right.
arrangement. Thank
Yeah,
you.
thank you.
Okay. Any other questions from anybody here? If not, I just want have the one questions. You mentioned about the synchronize the configurations, right?
Yes.
So when you do the synchronization, actually, is from your net console push to the device,
Yes.
or you from the device to the net console?
First of all, if you want to use NetConsole, you have to add information with to my tool, and for daily task, you should use my NetConsole. But the net, I mean, sometimes they do the command line by SSH, and we need to send the running config to our to my NetConsole, and I have a button we can click the button sync metadata. Please show me the slide, and it has the button help me to sync the latest configuration running config to the NetConsole.
Okay, so you take
That's that we not is we passing the running configuration to NetConsole value.
Okay,
Yeah,
so you take the last one.
Yes.
This one is the latest one, right?
Yeah.
Okay, okay. Thank you. So please give a round of applause to Tang for the presentations.
Thank you.
Okay, next speaker who is here, we have Sung Yi Yu, or some of you may know him as Steve Yi. Okay, so he will talking about the setting up the telecom grid temporary conferencing network. Okay, Steve is a student at one of the Taiwan University. Okay, and he also has some experience in network operations. So he will try to share the recent experience on how to build the conference network. Please welcome Steve in the stage. Yeah.
All right. So thank you, Aris, for introducing. My name is Tong Yi, and you can call me Steve just shortly. How can I use it? Okay. So I am an undergraduate student majoring in computer science in Taiwan, and my previous experience is focused on the Kubernetes networking and SDN, the software-defined network, which is the system and networking area. And I have some experience in a research at the National University of Singapore. So I'm original from Taiwan, but I live in Singapore for over a half year. I'm also a fellow in APNIC, APSIC, and APNIC policy fellow this year as well. So today I am going to present about how we build a temporary conference network, just like the APNIC do. So why I want to do this is, as a conference organizer, network is very important for attendees because it's just something like a human right. We need to connect internet to search the information or post something on the social media. Yeah, so or somebody might be able to meet in at a venue. So conference network is very important and it should be a little bit more stable. So we just copy how APNIC work. Yes, we try to apply the IP resources and S number and run our own BGP network with the ISP and NSP. So let's have some step. The first one is the topology should be how we connect to the internet from the venue. It should be um, um, like because the most IXP and network service provider is located in a data center. It's not around around the venue. So we need to resolve the issue between the data center and the venue connectivities. So we serve some resources. The first one is the layer one. This is the map we got. We searched it on our government. They have open data for us to check where the fiber connect and which fiber that who own which company we can ask. Yeah, this is the fiber, and as we can see, it's just some oh, it's just the green line is the fiber connection, and we can excellent to see how can we connect to our whatever connectivity or the data center. So this is how we survey. We go to check. This is the ISP. They go to check where is their fiber connection and how to connect to a building because our venue is in a building and they need to connect to the server and at the building first and back to our venue. And then is layer 2. We have some requirement purpose. The first one is it should be a long destination link, require the connection back from the value to the data center. And the second is we need to connect the different ISP and the internet exchange because the mostly is in a data center. So we need to resolve the issue between the value and the data center. And the third one is the minimal port speed should be the 10 gigabyte because we want to try. So, and then, oh, sorry. And our first idea is we want to use the dark fiber, but that is very expensive and it's very hard to get it. So we contact an ISP who has a less mile resources in Taiwan, and they help us to provide a layer 2 transport service between their data center and the venue. Yeah, and we also need the trunk port with the multiple VLAN because some VLAN we will use for our internal network. We don't want to let the external network to access. All right. So after resolving the layer 1 and layer 2, we need to connect to the internet finally. This is about the BGP, the layer 3 and IP resources. First of all is how we gather IP resources. So APNIC just there is a new policy which is regarding to temporary IP resources. It's just like we have a temporary conference for a week. We can apply with the APNIC and ask if they can temporarily allocated the IP resources to us, and they will us doing the assignment. Yeah, and regarding the S number, you can also use apply on behalf of this um, proposal, or you can just apply as a normal because there is nothing. I personally think there is nothing different. Oh, sorry. And regarding to the IP transit, I didn't put the list because I don't want to spare it which IP transit provider that we found. But finally, we just asked HE, the S6939, and the Taiwan Academic Network to help us to doing the temporary IP transit. It's just a one-day event, so later on a week for our testing and use. Then is BGP and OSPF, which is a routing protocol to let us dynamic to up to management our routing, because we have a switch side, we have a venue side and the data center side. So we use the OSPF for our internal network, and BGP just announce our prefix to the internet by through our IP transit provider. So how do we set up a Wi-Fi access point? This is for how we provide the internet access for our attendees, because it's very hard to provide the internet connection. So we got we landed on out of our AP 535. We have a 10, and we put the PoE switch at a venue, and that's all of our access point to connect by through the switch. The PoE switch also provide the power and network. Yeah. And second one is we cannot to break out the venue, so we need to find something like a camera tripod with a mount break, just like this camera. Yeah. So this is how we built. We made our own something like a mount key to stand up the Wi-Fi AP. Yeah. So we also to deploy self-service for our conference network for monitor, or yeah, for monitor. The first one is the networks. This is very useful for the network operators. We use it to allocate our IP address, like the tunnel IP, like the point-to-point IP address or BGP stations IP. We also doing the DNS configuration for PTR, and because we have some switch and server, so we use this netbox to list which server, which switch that we put at. Yeah, and it also supports the RESTful API and graphic API for management and integrated. All right, so we also build the BGP tools Looking Glass. This is a very cool service. We just run a multiple BGP station with the BGP tools, this website, and integrated. It just allow the user who can try to run the trace route on their website, or to see how the BGP route we learned. So like for this oh sorry. Like for this one, this is our router, and we learn the Google's property as prefix from the different aspects with the different upstream. And then is the RIPE Atlas. I didn't put the screenshot, but it's just testing the routing to see like how the routing from our site to Google public DNS server, or the HiNet or other overseas network. We also deploy the WireGuard VPN as a out of band management network. This is for our internal service like IPA and Grafana, or IPNI and routers, and we use a source net as a traffic to let our internal IP connect to the internet. All right, so we also deploy the archive model for this is for us to see how we traffic go. Like this one, as we can see, a lot of our a lot of our traffic connect to the HiNet, and this is a UDP, TCP, and other. And we can also spray which the source as number protocol, source port, destination port, which we just monitor, which we just mirror the flow to our server, and to see the monitor how we connect to. And then this is the Grafana monitor dashboard. This is our article. So this is the Redis, because we have built the edu roam. So we will see how the user connect to the eating room Wi-Fi, and it will separate data to the influx DB. And then it's a SNMP, it show how many users connect to Wi-Fi. And we are using a Linux VM as a router. So we use FR routing as a routing demo. It just run a BGP session with other service provider. And then it's a net stat. It can show what's the traffic that we run right now. And then it's a PN Act to show the net flow to the Akavoda, which I showed previously. Then Grafana will get the data from the different service to build a very beautiful dashboard. So this is a dashboard. We can see our interface. What is the traffic and interface, and IPv4, IPv6. Yeah. Okay, so that's all.
Okay, thank you, Steve, for a very good presentation. So anyone have questions for Steve?
Oh, I forgot to mention one thing, which is for the
Okay,
challenge
okay,
that we
please.
met.
We still have
we-
some time, no problem, you can continue.
We take a lot of time to communication, and communication still is a communication because the people is hard to control. So it's a big challenge for us. Yeah. Tom?
Thank you, Steve. Can you just go back to the slide where you have your GitHub repository? Yeah, no,
Which one?
where you have the URL. There you go, GitHub. Perfect.
This one?
That's what.
Okay.
Yeah, I want to copy.
So this is a tool that one of my team to build it because the origin this is written by Golang because we didn't find there some of our open source project to integrate it with the with our Linux router. So we just built something like, and I remember that is export the PN Act the net flow so we can monitor. Oh, this one. We just get to gather the traffic data from the Linux kernel side. So it just export.
Okay, any other questions or comments? Actually, just one questions.
Okay.
I think everybody also curious about that. How long you? You need to take from the first survey, which is the layer one, which
Yeah.
is the until the network or even the network ready for the event. How long it will take?
We take, let me think. We take about a half year to communication and survey because
Okay,
it's
half
very
year.
hard to find a provider who support us to do this.
So the half years means including all the like the tools development, integrations, testing.
Totally is several months, I think,
Several
because
months.
we just take a half month to a month to build everything once we confirm the resources.
Okay, okay.
Yeah.
Thank you, thank you.
Yeah. And APNIC networking is very strong because I hear that we might some problem in network connectivity and Wi-Fi, but they are fully support every time.
Okay, okay. Any other questions or comments? If no, maybe we can wrap up here. Okay. But before we end the sessions, I just want to announce that we have lined up for the lightning talk, right? I think if you still have time to, want to join some technical sessions, very quick one, it will be on 6 p.m., right? Oh yeah, the submission is closed, but you can see the schedule in the program website. So if you interested to see some of the talk, you can join at 6 p.m. in I think in the other room. Yeah, I think Danang 2 and Danang 3. Yeah. So with that, I close the sessions. Once more, we thank to all the speakers. See you in the next sessions.